In this video, we are going to begin talking about divisibility, focusing on the standards that we see and also definitions. So if you look in the South Carolina State Standards, we can see that divisibility comes up beginning actually in second grade, looking at the idea of even and odd. And we're going to talk about how this goes with divisibility, even though our students don't learn how to divide until third grade. In fourth grade, we're going to be looking at multiples and factors. We're going to talk about prime and composite in a different video. Right now, we're just going to focus on factors and multiples. And then in sixth grade, we're going to expand that idea to look at common factors, common multiples, the GCF, and the LCM, and look at how those things relate to what we're doing as a sixth grader. So some of the ideas between GCF and LCM we actually work on in fifth grade because we work with fractions in fifth grade. But officially saying this is the GCF or this is the LCM comes up in sixth grade. Same is actually true with even and odd. We can talk about the idea of even and odd with younger kids, but we don't necessarily have to have them identify things as even or odd until second grade. Okay, so here's the official definition of even. An integer is even if it has a remainder of 0 when it is divided by 2, and it is odd otherwise. Okay, well, that's odd, speaking of, because in third grade is when we start doing divisibility. I'm sorry, when we start doing division. So we're talking to students about something being even, which means it has a remainder of 0, when we haven't even talked about what division is or what a remainder is. So we're going to have other ways of looking at things being even and odd in second grade beyond the idea of a remainder of 0. So even though that is actually the definition, there are other ways of looking at whether something is even or odd. And one thing we're going to look at is the pairing of objects and counting by twos. So students will begin skip counting by twos quite early. So that's why even when my mom taught kindergarten, she could talk to her students about even and odd because they skip counted by twos. The idea of pairing things and putting things in groups of two, that can be done very, very early. And so to start building that understanding, again, even though officially we don't have to learn that until second grade, we can do a lot of background work before then. So if I had a room full of students and I wanted to do an activity and I needed everyone to have a partner, so I need to know if there are an odd number of students in my class or an even number of students in class. So pretend we're in one of those huge lecture halls and I need to know very quickly whether or not I'm going to be able to do my activity. So probably the easiest thing for me to do is just say, okay, everybody stand up and find a partner. If everyone can find a partner, if everyone can pair up, then I have an even number of students. If there is someone who cannot find a partner, or if we try to make a group of 3, sometimes we misunderstood partners to be groups of 3. That's very confusing. But if somebody doesn't have a partner, then the number is odd. And so that is a very quick way that I can determine without actually dividing or without actually counting how many students I have in my class. I can just have them line up and see if everyone has a partner. Okay, let's talk about some more things with divisibility. So this is a notation idea. We say that 3 divides 18, and we write it like this. That sort of looks like an absolute value bar in the middle, but this is 3 divides 18. And we say that that is true if the remainder is 0. So 3 divides 18 because the remainder is 0 when 18 is divided by 3. So if we were looking at that in a more general sense, B divides A would be written like this, and that is true only if B can go into A an even number of times with no remainder. So one thing we might choose to say there, we could say 6 divides 18, but we would not say 18 divides 6, right? Because 18 cannot go into 6 with a remainder of 0. So same thing here, we could say that 5 divides 25 because 5 will go into 25 5 times with 0 left over, but we would not say 25 goes into 5. 25 does not divide 5. So if it does not divide, the way we do that is we just take our little division thing and we put a slash mark through it. So 18 does not divide 6 and 25 does not divide 5. You have to be careful with the order in which you do division. And some of the biggest mistakes that I see in this class when people write out answers to word problems or they explain something to me on the test for this section is just they say it backwards. So you guys be careful with the way you say this. 6 divides 18, but 18 does not divide 6. I could say 18 is divisible by 6. That's okay, but not 18 divides 6. Okay, so check out this definition from the perspective of a fourth grader. Remember, we looked at fourth grade as we're going to be talking about factors and multiples. So for any whole numbers A and B, all right, and we're focusing on whole numbers here because in fourth grade, that's what we have experience with. So our whole numbers are 0, 1, 2, 3, 4, 5, the positive integers and 0, no fractions, no decimals at this point. So for any whole numbers A and B does not equal 0. Remember, we talked about that before the last test. It was important to throw out 0, so to speak, because 0 cannot be used as a divisor. We can say that B divides A if and only if there is a unique whole number Q such that A equals BQ. Okay, so first of all, that word should be whole, not while. So sorry about that. All right, there's a whole number. And if B divides A, then B is a factor of A, and A is a multiple of B. Okay, so first of all, we have this semi-confusing definition from a 10-year-old perspective. And then we just say this one is a factor and this one is a multiple. They're in the same definition. So you can see how this would be a confusing concept for your fourth graders, and they get these mixed up all the time. So one thing that would be really helpful, those of you guys who are going to be in those upper elementary grades, help them learn the difference between factor and multiple. Because the definition is written in this way, it's very confusing for them. So think about what happens here. B is a factor or a divisor of A. Divisor might actually be easier for them because we've been dividing since third grade and we're learning this in fourth grade. So that might be helpful. Factor and divisor are the same thing. And A is a multiple of B. So that means that A is equal to B times something. A is a multiple of B, and B is a factor. That means that B goes into A. B divides A. It is a divisor of A. So work with those definitions with your students. The idea here of if and only if, what that means mathematically is that it goes this backwards and forwards. So I can say B divides A if this number Q exists such that A equals B times Q, right? I take my number B and I multiply by something and I end up with A. And if that's true, then B divides A. It can also go the opposite way. So if and only if is just a mathematical thing that says I can read this sentence, quote unquote, forwards or backwards, and it means the same thing. I mean, it's true both directions. Okay, so let's look at these statements and let's determine if these statements are true or false. 3 divides 12 is that first one. Okay, what do you guys think? 3 divides 12. That's going to be true. 3 times 4 is 12. 3 goes into 12 4 times with a remainder of 0. Therefore, 3 divides 12. How about 0 divides 2? What do we think about that one? Well, that one's going to be false. Remember, we talked about when we were doing division that 0 doesn't divide anything. We cannot divide by 0. That gives us something that is undefined or indeterminate. So anytime you have 0 here on the left-hand side, that is not going to be a true statement. All right, how about this one? This one is confusing for people. 0 is even. All right, think about your definition of even, your official definition of even, and see what you guys think about this one. Well, that's a true statement. 0 divided by 2 is 0 with a remainder of 0. So because my remainder equals 0, it meets the definition of an even number. All right, this one. How would you read this one? Do you remember? This is 8 does not divide 2. Okay, true or false? 8 does not divide 2. That's going to be true. 8 cannot go into 2 an even number of times with a remainder of 0. 2 divides 8, but 8 does not divide 2. All right, for all whole numbers, 1 divides A. So no matter what whole number I have here, 1 divides A. Remember, the whole numbers are 0 and then the positive integers. That one is going to be true. So it's okay to have 0 on this side. Anything divides into 0. 0 is divisible by everything other than 0, but it's just not okay to have 0 on this side. 1, on the other hand, 1 divides everything, right? Everything divided by 1 is itself. For all non-zero whole numbers A, all right, so I've got back to those whole numbers again, only this time, look what it says. It says non-zero, so I'm throwing out 0. I'm only basically doing here the positive integers, 1, 2, 3, 4, 5, 6, on and on forever. A squared divides a to the 5th. Well, that's going to be true. Because I threw out 0, that one works out to be true. Remember the one we had in the last puzzle? It was not, 0 was not thrown out. 0 was still part of the question, and so therefore we had to say false. But in this case, because they have specifically said non-zero, we can say that this is true. All right, how about this one? 3 divides 6n for all integers n. All right, an integer there being positive or negative. Well, that's going to be true. Because 3 divides 6, then anything I multiply is going to be divisible by 3 as well. So 3 divides 6, so therefore 3 divides 6 times 2, 6 times 7, 6 times 459, 6 times negative 27. All of those things 3 will go into with a remainder of 0 because 3 divided by 6, 3 divides 6 to start with. All right, properties of division. So this goes with that last question we just did. For any whole numbers A and D, if D divides A, so notice the word if here because 0 is a whole number, right? And I said that 0 doesn't divide anything, but it says if. So if D divides A, so this automatically is throwing out the idea of 0 being here. And N is this other whole number. Then D divides N times A, which basically means if D is a factor of A, then D is a factor of any multiple of A as well. So think about what that means. This is like what we said before. 3 divides 6. So 3 divides every multiple of 6 as well. 6 times 2, 6 times 3, 6 times 4. No matter what I multiply 6 by, 6 times 100, 6 times 25, right? Any of those are going to be divisible by 3 because 3 divides 6 to start with. So I could split this into 3 even groups because I can split 6 into 3 even groups of 2. Then I can split any multiple of 6 into even groups. I'll just have more in it than the 2 that I had, right? This one I would have 4. This one I would have 6. But it's all because it was originally able to divide this one.